Yes, thank you.
reba aho hantu intebe yakomotse.
Hello, dear friend. We are going to discuss about an embedded system. This module composes hardware parts and software parts and some logical programming language. The prerequisite, what the requirement you need to know before start this course. You should be able to know electrical and electronics. In sum, you must know electricity concepts. You must know programming languages like C programming, C++ programming, Java. In short, C programming is enough. Okay. You must be able to use a computer. Maintenance, installation, uninstall, and so on. Okay, allow me to continue. Okay. The purpose of this module, at the end of this module, the trainee will be able to design an embedded system architecture, develop hardware device, develop embedded system firmware, and manage an embedded system. Okay. Learning outcome 1, design an embedded system architecture. If you deal with designing an embedded system architecture, you think that it involves creating a structured framework for an embedded systems, structured framework of an embedded system, which are specialized computing systems dedicated to specific a task or functions within a larger systems. Embedded system performs a specific task, perform a specific functions within a large systems. Embedded system is not multitasking. It is a single task performed. This process including defining the components, system components, interfaces, data processing capabilities to meet specific requirements such as performance, power consumption, and reliability. The embedded system architects need to consider various factors such as a hardware and software integration, real-time processing, communication protocols to design efficient and reliable systems. If you think embedded system, consider to those factors. Number 1, hardware. Do you have enough hardware? Do you have enough software compatible with hardware for integration? Real-time processing. Is it a time communication protocols? Do you have enough protocols, hardware, which can listen another devices by using protocols to design efficient and reliable system. Okay, those are the more examples of an embedded system: airplane, printer, and so on, car, vehicles, boat, and so on. What do you mean, the system? System is a set of interrelated parts or components which are designed or to perform common task or to do some specific work for which it has been created. A system is in combination, interrelated, integration, and installation of components on a single system unity that allows you to perform a specific task according to the purpose of creating that system. Thank you. Embedded. Embedded means including something with any for a reason. If you want to include something together, anything together for a reason, for a certain purpose, you mean embedded. Or simply, we can say something is integrated or is attached to another thing. You must clearly differentiate embedded and system. Embedded is the result of system is the result of embedded. You include, you attach some devices together for a reason. After, you interrelate parts and components which are designed or developed to perform common tasks. Those are the difference between system and embedded. Embedded including something. Embedded means attaching something to another. System, interrelated components of something for design and develop to perform common task or to do some specific work for which it has been created. So, what is embedded system? Embedded system is an integrated system that is formed as a combination of a computer hardware and software for a specific function. If you say the combination of computer hardware and software for a specific function, you mean embedded system. A set of computer hardware and computer software for a specific function, you mean embedded system. Here, it can be said as educated. dedicated computer system that has been developed for some particular reason. So, embedded system is an electronics and electromechanical system which is designed to perform a specific function and is a combination of both hardware and firmware software. Example, electronics toy is embedded system, mobile handsets, washing machine, air conditioner. Okay, those are the system interrelated of parts or components of an embedded system. We have embedded system. Number one, have a software. Software, we have two categories: operating system and the application. System inputs, system outputs. We have hardware, peripherals, devices, embedded system microcontroller as the system board. Peripherals, those are the devices that are plugged in together on your system, embedded or microcontroller, to perform, to make addition, to complete a specific task in its way and in a certain time. Typically, embedded system mainly has two parts. Number one, embedded system hardware. Number two, embedded system software. Embedded hardware are based on around microprocessors, and microcontrollers also include memory, buses, input or output systems, controllers, whereas embedded software includes embedded operating system and different applications and the drivers. Those are the software. If you say software, you mean the intangible part of computer, intangible part of embedded system that tells hardware embedded system what to do. It gives the instruction to hardware what to do, when, what, how, and so on. Some examples of embedded system: digital watches, watching machine, televisions, digital phones, laser printer, cameras, industrial machines, electronics, calculators, automobiles, mechanical and medical equipments. Medical equipments. Types of embedded system. We have two types of embedded system classified based on its performance and functional requirements, or performance of its microcontroller. So for the task of care, we will cover both of these classifications below. Number one, the types are categorized on this structure. Based on performance and the functional requirements, we have sub-types. Real-time embedded system, standalone embedded system, networked embedded system, mobile embedded system. Based on the performance of microcontroller, small scale, medium scale, sophisticated scale, small scale, medium scale, sophisticated scale. Okay. Based on performance and functional requirements. Allow me to explain one by one performance and the functional requirements. We deal with standalone, real-time, networked, mobile. In real-time, we have a soft real-time embedded system. We have a firm real-time embedded system. We have a hard real-time embedded system. Again, standalone embedded system. A standalone embedded system works by itself. It is a self-contained device which doesn't require any host system like a computer. It takes either digital or analog inputs from its input ports, calibrates, converts, and processes the data. The outputs of resulting data to its attached output devices, which either displays data or controls and derives the attached devices. They can produce outputs independently. Example, temperature measurements system. Temperature measurement systems, video game consoles, MP3 players, digital cameras, calculators, and microwave oven are the examples for the category which is called the standalone embedded system. If we say standalone, you mean electronic devices that work without any internet, work itself by using the help of battery only. Scientific calculator is a standalone embedded system. Yes. Fan and so on. They work themselves without relying on a larger platform. Okay. Real-time embedded systems. The real-time embedded system means there is an embedded system which gives the required output in a specified time, or which strictly follows the time deadlines for completion of a task, is known as a real-time system. It means a real-time system, in addition to functional correctness, accuracy, also satisfies the time constraints or limit. It gives a required output in a specific time, in a specified time, or which strictly the time deadline for completion of a task is known as a real-time system. If you perform a task under the specified time, you think and you mean real-time embedded system. There are three types of real-time system. There are three types of real-time systems: soft real-time system, hard real-time system, firm real-time system. Soft real-time system, hard real-time system, firm real-time system. Soft real-time system, firm real-time system, hard real-time system. Okay. Value, usefulness, deadlines, time. Okay. Usefulness, deadline, time, usefulness, values, deadline, time. Thank you. Soft real-time system. When a soft real-time system misses a deadline for a given operation, the operation does not immediately lose all its values. Instead of the value diminishes over time, it means it decreases toward zero as a time moves further beyond the deadline. Real-time system, which is the violation of time limitations, will cause only degraded quality, but the system can continue to operate is known as a soft real-time system. For examples, okay, examples, a microwave oven, washing machine, TV remotes, websites, computer games, cellular networks, online database, and multimedia transmission and reception, etc. Multimedia transmission and reception. Okay. Hard real-time system. A real-time system in which the violation of time constraints will cause a critical failure and the loss of life or property damage or catastrophe. This system usually interacts directly with the physical hardware instead of through a human being. The output must be completely on time. The prescribed deadlines cannot be missed in any case. You can't submit your exam paper after the time is over. This is a hard real-time system. You can't submit your exam paper after the time is over. Example, deadline in a missile control embedded system, delayed alarm during a gas leakage, a car airbag control system, a delayed response in pacemakers, failure in radar functioning, etc. From real-time embedded system, the timelines of a task are crucial, but the missed deadline can be compensated as it occurs daily. Missed deadline does not degrade the system performance. In case the system misses the deadline, the system continues to perform and discard the delay response. Example, financial forecasts. It is networked embedded systems. Networked embedded system. The networked embedded system are related to a network with network interfaces to access the resources. The connected network can be a local area network RAN or a wide area network, or the internet connection can be either wired or wireless. The networked embedded system is the fastest growing area in the embedded system application. The embedded web server is such a system where all embedded system devices are connected to a web server and can be accessed and controlled by any web browser for output generation. Example, home and office security systems, automated teller machines, ATM, point of sale POS system, mobile embedded system, a mobile embedded system. Mobile embedded systems refer to specifically to small, portable, embedded device like cell phones, laptops, calculators, digital cameras, MP3 players, PDA, personal digital assistants are the example for a mobile embedded system. Embedded systems. The basic limitations of these devices is the limitation of memory and other resources. KB types of embedded system based on performance of microcontroller. Types of embedded systems: small scale embedded systems, medium scale embedded systems, sophisticated embedded systems. Classifications of embedded systems: small scale embedded systems, medium scale embedded systems, sophisticated embedded systems. A small scale embedded systems. This embedded system can be designed with a single 8 bits or 60 bits or 16 bits microcontroller. It can operate with a help of a battery. Yes. As the name suggests, a small scale embedded system makes use of small size microcontroller ranging from 8 bits to 16 bits. They are less complex in terms of hardware and software and can be operated with batteries as well as because of their smaller size. Mostly, the C programming language is used in such embedded system. Example, wearable devices, smartwatches, and health monitor equipped with sensors and microcontrollers to track activities, monitor health parameters, and provide notifications. Sensors. Thank you. Medium scale embedded systems. These types of embedded system are designed using 16 bits or 32 bits microcontrollers. These systems offer both hardware and software complexities. C, C++, Java, and source code engineering tools, etc., are used to develop this kind of embedded system. Example, ATM machine, which is widely used by us nowadays, has a medium-scale embedded system in it. Sophisticated embedded systems. These types of embedded systems are designed using 32 bits or 64 bits microcontrollers. This type of embedded systems has a lot of hardware and software complexities. These systems are designed for performing a complex tasks and functions. Example, modern day air conditioning, medical engineering system. Applications areas of an embedded systems: home appliance, transportation, healthcare, business sector, and offices, defense sector, agricultural sector, computer peripherals, computer networking systems, measurement and instrumentation. Characteristics of an embedded system. Characteristics of embedded system: perform a specific task. Number one, low cost, time specific, low power, high efficiency, minimal user interfaces, less human intervention, highly stable,
Less human intervention.
high reliability, use microcontrollers or
Neno zose ko mbona wazijyanye
microprocessors.
perezida azatora twicira
This is
source zero